Today I will talk about beam grid structure system. Here is presentation content. I will start with definition. Beam grid system is a reusable structural system that allows you to dream up and build complex projects faster than any other construction technology. This modular construction system, which was developed in 1976, is based on beams with a simple geometry and a repetitive hollow pattern. The beams can be made of wood, aluminum, steel, or any other material. This photo to show how the beam grid system is. For the history, grid beam system was inspired by a system innovated by Ken Iskas in the 1950s. Living structures which used similar beams but contained only a few walls. The system originated with the work of designer Ken Iskas in the 1960s, who, being among the early post-industrial futurists, believed it was necessary for the public to become actively involved in the design and creation of the built habitat around them. The photo is shown a girder, beam, and column. Classifications of beam grid system: it can be glued wood metal steel or glued wood liyan. Classifications of beam grid system: there's three types: homogeneous grids, gradated grids, and concentric grids. Let's start with homogeneous grids. Orthogonal grids. The orthogonality of a grid is characterized by the intersection angle between the grid lines. A grid is called orthogonal if all grid lines intersect at a right angle. Two-way orthogonal spatial grid frame. Vertical plane trusses in two directions intersect perpendicularly, parallel to the boundary direction. For diagonal grids, the D-grid, it's the same as diagonal grids, is a framework which is composed of diagonally intersecting beams and used in the construction of buildings and roofs. Dia-grid structures are usually used for high-rise buildings. The most common material that is used in these structures is steel. This structural system brings together the opposition resistance to gravity and lateral loads with a triangulated system. These triangulated members allow the elimination of the traditional vertical columns. Triangulation is provided where the floor beams get together with the grid, the part that the diagonal elements connected to each other named as nodes. Being single thickness differentiates the dia-grid from any three-dimensional triangulate systems, such as space frames, space trusses, or geodesic structures. Here is a photo that it shows node, horizontal pressing ring, and shows the diagonal grids. Here's also the high-rise buildings that has diagonal grids. Here is how the load is going inside the diagonal grids. For triangulated grids, three-way grid frame, the vertical plane trusses in three directions intersect each other at an angle of 60. The grids in the upper and lower chord planes are all geometrically invariant triangles. Therefore, the grid is a geometrically invariant system composed of a number of stable triangular prisms as the basic unit. Skew grids. When the overall shape of structural grid does not approximate a square, structural and economic efficiency can sometimes be gained by employing a skewed grid. Concentric grids. The structure is characterized in the auxiliary grid lines shaped like circular rings are distributed in a concentric manner, and a center of circle of each auxiliary grid line is superposed with a center of circle of the round. Each auxiliary grid line is shaped like the circular ring to allow the length of each auxiliary grid line to be greatly increased. thereby improving the capacity of charge accumulation. Moreover, each auxiliary grid line is at least connected with two main grid lines, so that connection is reliable. The load distribution in beam grid system. A load set on a cable or a beam is channeled to the support along the cable line or the beam axis. An arch, a frame, and continuous beam produce the same type of one-directional load dispersal. These structures are labeled one-dimensional resisting structures because they can be distributed by a straight or curved line, along which the trusses channel the loads. If they are used to cover a rectangular area, the system becomes impractical and insufficient. Grid beam structures are two-way load dispersal system. When two identical simply supported beams at right angles to each other are placed one on the top of other, and concentrated load is applied at their intersection, the load is transferred to the supports at the ends of both beams and dispersed in two-way direction. Being identical, they have same deflecting and carry half the load. Thus, each support reactions equal to 1/4 of load. Here is also a picture that showed the load on two-dimensional system. The construction examples. Grids are generally limited to the interior of slab, leaving one or two of the forms out to create a solid fill around the supports. The solid fills provide the strength required for shear transfer to the supports. The fills also reduce the convergence stresses at the soft of the floor around the supports, thus avoiding the necessity of bottom reinforcement in this region. These photos are show how it apply. Construction techniques. There's a lot of construction techniques, but one of it arranging the framework, fixing the containers, fixing the framework, providing a horizontal container, connector placing the pods, fixing pods to the concentric connectors, removing framework, removing connectors, removing pods, providing stack. Here's some details about reinforcement details. Of sloping slab and grid system, of wall and grid slab, of beam and grid slab. Some case studies, like Metropole Parcel, Italy. It's the world's largest wooden structure which is made up of waffle system. Chhatrapati Terminal, India. It's recognized for its innovative column design, which also consists waffle design. Also Museum of the Parque Fortaleza, Brazil, and the Communication Development Center of Spain. Here is famous company of grid beam system. Here's the references. Thank you for listening.